Okay, today we're looking at section 6.4, special parallelograms. We're going to start with two theorems. Theorem 6.9, which says each diagonal of a rhombus bisects two angles of the rhombus. And then theorem 6.10, the diagonals of a rhombus are perpendicular. So, regardless of which diagonal we're talking about, if it's a rhombus, which this one is marked as a rhombus, when I draw a diagonal, it's going to bisect both angles that it intersects. And the other one would also. That's what theorem 6.9 tells us. And then theorem 6.10 tells us that the diagonals are perpendicular to each other. So we can use this information to sometimes find measures of angles in different figures that we don't know. So in example 1, MNPQ is a rhombus. They tell us that, which means we know all the sides have the same length. And they're asking us, they also tell us that measure of angle N is equal to 120 degrees, and they want us to find the measures of the numbered angles. So if we look at the triangle MNP, where we know the 120 degree angle is located, we can look at this triangle and see that it's an isosceles because it has two sides that are the same length. The isosceles triangle theorem, or the converse, I'm not sure which one, tells us that if we have an isosceles triangle, the angles that are across from those sides are also congruent. So we know that the measure of angle 1 has to equal the measure of angle 3. And we also know, since angle N is 120 degrees, that when I add up all three of those, I should get the 180 degrees. So that tells me enough that I can figure out what the other two angles are. Okay, so I would be subtracting 120 from 180, and that would tell me that measure of angle 1 plus measure of angle 3 should equal 60. But they're both the same. So I could say 2 times the measure of angle 1 equals 60. And so that would give me measure of angle 1 equals 30, which is the same as measure of angle 3. Okay, so once we know that, then we're going to use theorem 6.9, which tells us that the diagonal bisects the angles. So at NPQ here, 3 and 4 are the angles that are cut off by this diagonal that we know is bisecting it. So that means measure of angle 3 has to equal measure of angle 4. And at the other end, at M, angle 1 and angle 2 are also going to be the same because that diagonal bisects the angle at M. So measure of angle 2 is also equal to measure of angle 1. So all of those are 30 degrees. Okay, so try a quick check 1. Just pause and see if you can work this out. They've given you that this is a rhombus again, and you're looking for the measures of the numbered angles. Okay, hopefully you tried this before you're watching the solution. So all of these are the same. That may or may not help us. I'm given a 50 degree angle that's hard to see, but at the top here. So I can look and figure out if there's some way that I can know what those other angles are. One is at the intersection of the two diagonals, which theorem 6.10 told us that they're always perpendicular. So that's one thing that I know. Measure of angle 1 has to be 90. Okay, and so then we just have to see how we can use that to help us. All right, so if angle 1 is 90, then let's see what else we would need to know. Angle 3 is going to be, angle 3 and angle 2 are going to be equal to each other. My pen's not working today. Okay, so I can look and remember that not only are the sides all the same, they're also parallel to each other. So if I think of this diagonal as the transversal, and the top and bottom of the rhombus as the parallel lines, then I can see that the angle that's marked 50 degrees is an alternate interior angle with angle 2. So that means measure of angle 2 has to be 50, and we said that measure of angle 3 has to be the same because the diagonal is bisecting the angle. So both of those are 50 degrees. Now we're just left to figure out what angle 4 is. So again, remember when the diagonals intersect, they intersect and form perpendicular lines. So this is a right triangle. It all has to add up to 180. 90 plus measure of angle 2 is 50 would make 140. So angle 4 must be 40 degrees. Okay, now let's look at another theorem, 611. This one is not talking about a rhombus, but another special case of a parallelogram, which is a rectangle. So remember, the rectangle is has opposite sides are parallel, but it has 4 right angles. So this one says the diagonals of a rectangle are congruent. So this time I'm not looking at this thinking that they intersected a perpendicular, they don't make perpendicular lines for the diagonals, but they are the same length. So in example 2, they're asking me to find the length of the diagonals in this rectangle GFED. If FD equals 2y plus 4 and GE equals 6y minus 5. So all I'm going to do is just set those two equal to each other. I don't know why this is not working. And I'm just going to solve for y. So I'm going to get 4y equals 9. And then I would divide by 4, so I get y equals 4/9. I'm sorry, 9/4. Now they did ask me not just for the y, but for the length of the diagonal. So I just need one or the other. They're both going to be the same. So I'm just going to do FD. So that would be 2 times 9/4. Fours keep looking like a y. Plus 4. So that's going to give me 18/4, which I could reduce to 9/2, plus 4. And 4 is the same as 8/2. So when I add those together, I'm going to end up getting 17/2. Or you could say 8.5. Okay, oops, wrong one. Okay, so quick check 2 is asking you to do pretty much the same thing. We still have the same rectangle, and they've given you different values for FD and GE, and they ask you to find the length of each diagonal. So stop, pause, and try that. Okay, so hopefully you set these two things equal to each other, since the diagonals have to be congruent. You're going to end up with 4y equals 14. And y is 14/4, which I can reduce that to 7/2. Okay, that's the variable y, but I did need to go back and plug it in to find what the lengths of the diagonals are. So the easiest one to plug it into is GE this time. Just putting it in for y, so it's 7/2 plus 5, which 5 is the same as 10/2. So I can just add 7/2 plus 10/2 and get 17/2, which is what we had before, so 8.5. Okay, there are 3 final theorems, but what these are the converse of the ones we just talked about. So theorem 612 says if one diagonal of a parallelogram bisects 2 angles of the parallelogram, then the parallelogram is a rhombus. So you have to be looking at only one diagonal to see if that's true. And this one's a rectangle, so it wouldn't be the case. But if I can look at one diagonal and see that it bisects both the angles that it touches at the corners, then I know the parallelogram is a rhombus. Okay, Theorem 613 says, if I have diagonals of a parallelogram that are perpendicular to each other, then the parallelogram is a rhombus. So that's the converse of the second one we saw, 610. And then the last one is the converse of 611. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we're going to be looking for the first part, the hypothesis, and if we can find that that's true, then we'll know that the parallelogram is a certain type. All right, so example 3 asks for us to look at these pictures and decide if we can conclude that the parallelogram is a rhombus or a rectangle. And when they say explain, they just want us to tell which theorem would give us the answer here. So looking at part A, I know it's a parallelogram, they told me that. And I have one diagonal that's bisecting each angle that it touches. So this one would be a rhombus. And that would be by Theorem 612. Okay, the second one on B, I know it's a parallelogram. I'm given that the diagonal AC is congruent to the diagonal BD. So this one would be a rectangle. And that is by Theorem 614. I think that's the right number. Okay, so the final thing is to look at Quick Check 3. This time they don't give us a picture. They tell us that a parallelogram has angles of 30, 150, 30, and 150. And they're asking if we can conclude that it's a rhombus or a rectangle. So stop and see if you can figure that out for just a minute. Okay, so I'm just going to draw a picture in. We'll see what we think. So we have, oh, that's not a good picture. 30 degrees, 150, 30, and 150. So the question is, do we have enough information to say that it's a rhombus or a rectangle? The two theorems that we could use for the rhombus were that either the diagonal bisected, one diagonal bisected two angles, or the diagonals were perpendicular to each other. And then for the rectangle, the diagonals need to be congruent. So this time, because they just gave us the measures of the angles, they didn't give us any other information. They didn't draw any diagonals in. They didn't tell us anything about what the diagonals did. We do not have enough information to say it's a rhombus or a rectangle. Okay, so work the problems for section 6.4 and I'll see you in class.